In the last segment, we laid out some of the most popular rationales that underlie non-speech oral motor treatments. Now we'll look at these arguments one by one. First, the part-whole issue. Everyone on all sides of this debate agrees that speech movements are highly complex, and that they typically involve several interdependent parts. The broader motor learning literature has looked at learning of many complex motor tasks that involve similar properties, in particular that the movement requires coordination of interdependent parts. And the result of this work is that decomposing the target behavior does not seem to facilitate learning of these kinds of complex movement patterns. Instead, learning tends to be more accurate and faster with segmented tasks only when the parts of the task are independent of each other. This is not the case for speech movements. Now, the technical terms for these ways of breaking a complex task down include fractionation and simplification, and the current literature suggests that this is not the way to go when looking for gains in speech. The next argument advanced for non-speech oral motor treatment is to strengthen the articulators. This argument is often based on two observations: that kids sometimes look like they have lower resting tone in their orofacial musculature, and that speech sounds sometimes sound imprecise in kids with speech sound disorders. Rarely is the strength of the articulators directly tested. Instead, it's inferred from acoustic characteristics and/or visual inspection. The studies that have been done that look at the strength requirements for articulation among normal speakers indicate that the articulatory musculature is much stronger than it needs to be in order to produce speech. In fact, speech typically requires only about 20% of the maximum strength that articulators are capable of producing in non-speech contexts. On the flip side, some studies have evaluated strength demands among speakers with known decreased tongue strength. Adult speakers with dysarthria, in which tongue strength was about 50% of normal, were completely intelligible. Difficulties with intelligibility didn't begin to be measurable except in speakers whose tongue strength was below about 30% of normal. The implication of this research is that articulator strength, per se, has fairly low requirements. Certainly some strength is necessary, but the criterion for strength of the articulators of speech is not very high. It's quite likely, in fact, that if a given speaker has insufficient strength for speech production, we would likely see substantial, perhaps extreme, symptoms in other non-speech tasks that have substantially higher strength requirements. In other words, it would not be likely that speech would be the first place where you would see the main effects of a real strength deficit. And, in fact, some research has been done looking at the actual strength of the articulators among people with speech sound disorders. In these studies, no significant differences were found in tongue strength among children with speech sound disorders compared with children without speech sound disorders. And one study, in fact, found that kids with speech sound disorders might have even more lingual strength than kids without speech sound disorders. So again, the implication of these studies is that kids with speech sound disorders, as a group, should not be expected to have decreased strength of articulators. And when you think about it, this makes sense, because we already have a word for people who have decreased strength of their articulators. That word is dysarthria. And that's not the word we use for children with speech sound disorders. While it might be possible to define a subgroup of children who have decreased strength of articulators, that subgroup has not been fully defined to date. In the next segment, we'll evaluate some other proposed arguments about why non-speech oral motor treatments should work and see what the research has to say about these proposals.